The structure of functional group carbonyl is carbon, double bond O. There are two types of carbonyl compounds, aldehyde and ketone. The difference between aldehyde and ketone, aldehyde has one hydrogen atom attached to the carbon bonded to oxygen, while for ketone there is no hydrogen atom attached to the carbon bonded to the oxygen. The general formula of carbonyl compounds is CnH2nO. Naming aldehyde. Parent chain must contain the CHO group, C double bond O with hydrogen attached to the carbon, and the CHO carbon is numbered as 1, but omit this number from the name. What does it mean? It means, for example, this ethanol, 2 carbon, al at the back because it's aldehyde. So this carbon you count as carbon number 1 because it has carbon double bond O, and this carbon number 2. So if you change the position of the oxygen, the double bond O, to this carbon, you will count this carbon as carbon number 1. When the number doesn't change, if you change the position of oxygen, so you don't put the number while naming the aldehyde. Let's look at the example for propanol. For this propanol, this carbon will be carbon number 1. If you change the position of this oxygen to this carbon will be carbon number 1. This oxygen cannot be on the second carbon because it will be ketone, not aldehyde anymore. So at this carbon number 1, when you put oxygen here, and this carbon will be carbon number 1 when you put the oxygen here, the number doesn't change, so you don't have to put number 1 in front of the propanol. So it's just propanol. For this one, find the longest chain of the compound with the functional group carbonyl. So the longest chain is 1, 2, 3, 4. So it's butanol at carbon number 1, and then at carbon number 2 and carbon number 3 you have methyl group, so 2,3-dimethyl butanol. Remember, there is no 1-butanol because if you put this oxygen at the carbon here, this carbon will be carbon number 1. Next, the longest chain is 5, 1, 2, 3, 4, 5, so it's pentanol. Carbon number 1, carbon number 2 consists of ethyl substituent, and then carbon number 4, methyl substituent. So 2-ethyl, 4-methyl pentanol. E first and then M. When the CHO group is attached to a ring, it's cyclic ring, not aromatic ring, you'll call it carbaldehyde. So for example here, it's cyclohexane carbaldehyde. Omit carbon number 1 because if you change the position of CHO to this carbon, it will still be number 1. If it's on this carbon, it will still be carbon number 1, and if you change the positions at any of these carbon, it will still be carbon number 1. So you don't put cyclohexane 1 carbaldehyde or 1 cyclohexane carbaldehyde, you just omit the carbon number 1. Next example. So it's still cyclohexane carbaldehyde because carbon number 1 with functional group carbonyl, and you have ethyl at carbon number 2, so the name will be 2-ethyl cyclohexane carbaldehyde. If you refer to this compound, you will notice that there are two different functional groups in this compound, which are carbonyl and hydroxyl. If you refer to the priority table functional groups, carbonyl has higher priority than hydroxyl, so carbonyl will be the parent instead of hydroxyl. So carbon number 1 will be at the carbonyl, C attached to carbonyl functional group. So the parent name will be cyclopentane because we have 5 carbon cyclic, cyclopentane carbaldehyde, and the hydroxyl will be substituent and it attached to carbon number 2. So it's 2-hydroxyl cyclopentane carbaldehyde. The CHO has higher priority to other functional groups except carboxylic acids and its derivatives. So for example, here we have carbonyl and halogen. Carbonyl has higher priority, so the parent name will be heptanol because it has 7 carbon. And substituent methyl at carbon number 3 and bromo at carbon number 4. So 4 bromo, 3 methyl. Bromo first because B and then M. And then for this compound, butanol, as I've said before, carbonyl has higher priority than hydroxyl, so carbonyl will be the parent, so the parent name is butanol, and hydroxyl will be the substituent at carbon number 3, so 3-hydroxybutanol. So the common names that are widely used for one carbon with functional group carbonyl, methanol, the common name is formaldehyde, 2-carbon aldehyde, acetaldehyde, and benzene ring with aldehyde, it's benzaldehyde. Naming ketones. The parent is the longest one that contains ketone group and the numbering begins at the nearer to carbon double bond O carbon. If you count the carbon from the left, the carbonyl group will attach to carbon number 3. And if you count from the right, the carbon attached to carbonyl group will be carbon number 4. So the N nearer to C double bond O carbon is when you count the carbon from the left, which is this carbon will be number 1. So the name will be 3-hexanon. For this one, if you count from the left, this carbon will be carbon number 3, and if you count from the right, it will still be carbon number 3. So it doesn't matter. So you can count it from the left or the right. So for this one, at carbon number 2 and carbon number 4, you have 2 methyl groups, so it's 2,4-dimethyl-3-pentanone. For this compound, the carbonyl group, you count as carbon number 1 and carbon number 2 with methyl group, so 2-methyl-cyclopentanone, ONE, as a ketone parent name. Next, carbon number 1 will be at the carbonyl group, so carbon number 3 here at isopropyl, this is the shape of isopropyl, and then at carbon number 4 is methyl. If you count this carbon, carbon number 1, and this carbon at carbon number 2, this carbon will be at carbon number 4 and this carbon will be at carbon number 5. We prefer the lower number for substituent, so you have to count carbon number 1 and carbon number 2 on the right. Group has higher priority to other functional groups except for carboxylic acid and its derivatives and aldehydes. So here you have ketone, which is carbonyl group, and you have alkene, carbon-carbon double bond, so ketone with carbonyl group will be the parent because it has higher priority. So it consists of 6 carbon, so hexanon, but you have to put the number for ketone, so ketone, the carbonyl group at carbon number 2, and you still have to put the number for carbon-carbon double bond, which is at carbon number 4. So the name will be 4-hexene 2-on. So you remove the E here and replace with O and E. Next one. The longest chain containing ketone is 5, so 2-pentanone. 2 because this carbonyl at carbon number 2, And then at carbon number 4, you have both hydroxyl and methyl. So it's 4-hydroxy, 4-methyl. Don't forget to remove the L. The functional group for alcohol is hydroxyl, but when it becomes substituent, you only write hydroxy with no L. This one, 2-cyclohexenone. So for this carbonyl group, ketone carbonyl group, if you change the position of double bond O to this one, it will still be carbon number 1. And if you change it to here, it will be carbon number 1. If you change it to here, it will be carbon number 1. So you don't need to put 1 on, because if you change the position of the functional group, the number will still be the same. So you don't need to put number 1. For this carbon-carbon double bond, if you change the position of this carbon-carbon double bond here, it will be at carbon number 3. And if you change it to here, it will be at carbon number 3 again, because you start counting from the number 1 here, and number 2, and number 3. So if you change the position of this carbon-carbon double bond, the number change, so you have to put the number in front. So it will be 2-cyclohexenone. You have two classes of compound with the same functional group. It is aldehyde, and this one is ketone. Their functional group is carbonyl. So when you have aldehyde and ketone and the same compound, aldehyde will be the parent if you refer to the functional group priority table. So the ketone will be substituent. The name of substituent for ketone is oxo. So this compound name is 3-oxopentanol. Common names for ketone. So if it's propanol, it's acetone, and ketone with benzene ring, it's acetophenone, and 2-benzene ring ketone is benzophenone.